Hello friends, welcome to my channel Civil Methods. This is the column analogy method for Potter frames. Okay, only for Potter frames having total indeterminacy up to 3 degree, and total indeterminacy means internal indeterminacy plus external indeterminacy, and the generalized quantum flexure formula. Let stress at xy is a plus bx plus cy, and a, b, c are arbitrary constants. Now we know that stress is load per unit area, and for small area dA we can write load is integration of f dot dA. Now by this equation and this equation we can write load is this, and now this term will be equals to 0 and this term will be equals to 0. Why? Because when principal axis is passes through centroid, so at centroid x is 0 and y is 0. Thus p is equals to a dA integration. Now a arbitrary constant is p by a. Now bending moment about x-axis is p dot y, and bending moment about y-axis is p dot x. P is the total load. From this equation, m about x is multiplying y by each term. This will be again 0, and this term will be equals to moment of inertia about xy, or product of inertia, and this will be moment of inertia about x-axis. So bending moment about x-axis is bixy plus cixx. Now bending moment about y-axis is p dot x, and p from this equation, multiplying this equation by x, thus myy is now again integration of x dA is 0, and this will be moment of inertia about y-axis, and this will moment of inertia about xy-axis. Now we have two equations and two unknowns b and c. By this equation we can write c is equals to and now putting this c in this equation, now taking b common from these two terms, now b is equals to Now multiplying and dividing with minus sign. Okay, thus B will be this, and we can determine C by putting B in this equation. Thus C will be now F is equals to A plus BX plus CY, and A we already determined. A is P divided by A, and B is this, multiply by X, and C is this, multiply by Y. Now when any axis or any principal axis is the axis of symmetry, then Ixy is 0. Putting Ixy 0 in this equation, Ixx to Ixx, Iyy to Iyy cancels, and F is equals to this formula is used for beam problems, and this formula for Porter frames. Now for the sign convention, if this is the Porter frame and xy is principal axes, then first quadrant, second quadrant, and third quadrant, and in this quadrant xy will be positive, x and y positive positive, and in this quadrant xy negative positive, and negative negative, and positive negative.